Hello and welcome, I'm your CodeMonkey. In this lecture, we're going to learn all about events. This is another extremely powerful feature of C#. It helps us write much better code with much fewer dependencies. Okay, so events. This is basically how you can have one class, and that class fires off events when something happens, and the subscribers that listen to that event, those will be notified whenever that event happens. For example, here's a working demo. So there's a tower and I can click to damage it, and by using events, we can have some kind of health bar, and that health bar is listening to when the tower takes damage, and when it does, the health bar listens to that event and updates its own state. So the UI element over here, this one is listening to the build damage event itself, and then updates the health bar. Events have publishers and subscribers, or sometimes subscribers are called listeners. Those two terms are really used interchangeably. The event is defined within some kind of class, and then you can listen or subscribe to that event from anywhere else. Now, what that means is that when the event is invoked, all of the subscribers, those all get notified that the event happened. And note how this relationship only goes one way. So the subscribers attach to the event in order to be notified, but the event publisher, this one has no idea that there are any subscribers. This is really excellent for keeping your code decoupled. The event publisher does not know and does not need to know if there are any subscribers at all. Maybe there are some, maybe there are none, it does not matter. The event publisher itself is completely decoupled from any subscribers. As far as the event publisher knows, it just knows that it fired off an event. That's it. It does not know and does not care if anyone is listening. And the other benefit of using events is that our code can be based on when things happen as opposed to constantly polling for something. For example, over here on this demo, the health bar does not have to constantly poll the tower to check its health state on every single update, so it does not have to ask that question 60 times a second. The health bar is perfectly idle. It only listens when the event is published, so only when something actually happens does the health bar take action. Here in the code, the tower script, this one has an on-damage event. Then this demo is really super simple. I'm just asking for the mouse click, and if so, calling the damage function. And damage function simply alters the health amount and fires off the event. Again, note how this tower does not know anything about any kind of health bar. It is completely decoupled. And then on the health bar itself, this one does know that tower exists. It attaches itself to the on-tower on-damaged event. And when that event happens, it simply updates the health bar. So in order to show how the code is decoupled, I can just go ahead and get rid of the health bar. So I can just disable this game object, and yep, everything does work, because the tower does not depend on the health bar. Okay, so that's a quick overview of events. Now let's see the syntax. And the way that we make events is actually super simple. This lecture will be really easy to understand because we already learned about delegates, which are quite closely related to events. First, we write our access modifier. And usually for events, you do want them to be public. You want it public so that any other classes can listen to that event. It doesn't make much sense to have one event that is only listenable from that class, so usually events are public. And then we add the keyword event, all lowercase. This is a special keyword. Then we add the delegate. And like we covered in the delegates lecture, we can define our own custom delegate, or we can use the built-in action, for example. So let's use this one just because it's so easy. And then we give it some kind of name. Usually the convention is to start your event names with on, and then whatever happened. So for example, on player damaged. Simple like this, and in terms of naming rules, events are usually Pascal case, just like properties. Okay, so great, so just like this, we have defined our event. Now let's write a quick demo, just see how it works. And for that, let me actually just put this inside a basic player class, just so the demo makes a little bit more sense, so put it inside there. And now let's make some kind of damage function, so let's call it damage. And now here, the first thing we can do with our event is simply fire it. And for that, we do it pretty much as if this was a normal delegate and we were just calling it. So let's go on player damage and simply call it like this. So that's it, super simple. However, this code will actually throw an error, but let's test it like this. Up here, let's just create a new player. Just construct a brand new player, then on player, let's call damage and let's test. And if right away we have an error, we have a null reference exception. So this has to do with the fact that this event currently does not have any listeners. If it has no listeners, then this field is essentially set to null. So before invoking an event, we need to check if it has some listeners. And we can do that just by checking against null. So if the event is not null, if so, then that means it has some listeners, so we can safely call that event. So like this, if we run, and you have no errors, although also nothing happened. So now that we are correctly firing off the event, let's add in listener. Let's make another class. Let's make it a class and call it player health bar, something like this. And now in order to listen to the event, we need some kind of reference. So let's actually make a constructor for our player health bar. And in the constructor, let's receive an object of type player. So we receive that, and now here we can go through the player. And now we can indeed access the on player damage event. Also here in Visual Studio, it shows this little lightning bolt. This means an event. So we can access that event, and then we can do plus equals in order to subscribe to that event. And here, by the way, Visual Studio has this real nice shortcut. It is going to auto-write the player on player damage event, so just press tab to insert. Usually I do this. Then if you want, you can rename it or just press enter, and yep, there's our event function. Now, if you don't see this shortcut, or if you're using a different ID, you can just manually write this function. It's a pretty basic function. The only important thing is, just like we covered in the delegates lecture, the function signature needs to match event signature. So in this case, for the event, we made it of type action, which means it must return void and must have no parameters. Okay, so here we are listening to the event. Let's just do a log, so console.writeLine. Let's just print out the onPlayerDamage event, just like this. And now up here, let's construct our player health bar. So let's construct a brand new one. Let's make it. And this one requires a reference to our player, so let's pass it in. So first we create the health bar, and then we call damage on the player. So now basically what will happen is, when we call damage, the player damage, this one is going to fire the onPlayerDamage event. It is going to check against null, and since we have a listener, this one is not going to be null, so it is going to run our event. And by running that event, it is essentially going to run this code and print this line. So let's see. And if there it is, the event was fired and the listener did listen to that event. Alright, awesome. Again, note one of the big benefits about events. The player class, this one has absolutely no relation to the player health bar. So the player class is completely decoupled from the player health bar. As opposed to, for example, if we were to make this public, and then up here we would have some kind of private field of player health bar, then we would need to keep this reference, and in doing this on the damage, we would call the player onDamage function. If we did this, then the player class would be tightly coupled to this one. So for example, if I remove this one, obviously there are errors because this type no longer exists. Whereas if we go back to what we had previously, here is just the event, here is just the player class, and if I completely remove this one, yep, there are no errors inside the player class. This is what it means to be completely decoupled, is that the player class does not know and does not care if anything listens to that event. If it does, then great. If not, then also great. Then one important thing about events is how multiple classes can listen to one event. For example, if over here I make another one, let's make this a mana bar. So do it like this, do it pretty much the same, and over here let's say mana bar something. And then up here, if we construct a new of type this, if we do it, then now we have two listeners to this event. So when this fires, it is actually going to run both of these listeners. And if there it is, both of them did run. So events can be listened to by multiple listeners. And then over here, we are subscribing. But if you want at some point to stop listening to that event, you can simply swap the plus equals to minus equals. And yep, with that, we can unsubscribe. And at this point, I should point out that unsubscribing to events is actually very important. If you don't, then you might end up with memory leaks, depending on the lifetime of the object. If the listener gets destroyed, but the publisher lives on, if so, then it will actually keep firing events onto a listener that no longer exists, so that could cause all kinds of issues. So always keep that in mind. Either pay attention to the lifetime of the objects, because if the player has the same lifetime as this one, then technically you don't need to unsubscribe. But if they do have different lifetimes, if so, then when this object gets destroyed, make sure you unsubscribe to that event. So yep, we can either do plus equals or minus equals to subscribe or unsubscribe. And on the class that defines the event, we can also call the event. And now right away, you might be thinking that this looks exactly like delegates, especially the delegate multicast function. And yep, that's right, this is indeed very similar to delegates. In fact, if over here I just remove the event keyword, if I do, nope, nothing changed, there are no errors. And if we run this, yep, everything still ran exactly the same. So technically it works like this. However, adding the event keyword had some really useful limitations. First of all is who can trigger that event. If we do not add the event keyword, then anyone with access to this event can invoke it. So for example, down here on the player health bar, I can go on there, call it, and yep, this will work. So this player health bar will be invoking this event. Usually you do not want this. You want the class that defines the event to be the only one that can actually invoke the event. And if you add the event keyword, then the compiler actually enforces that rule. So yep, down here, nope, it cannot call it. The event can only appear on the left-hand side of a plus equals or minus equals, so subscribing or unsubscribing, except of course when used from within the player class, within where the event was defined. So the event keyword is really nice for essentially protecting you for yourself. Remember how the main clean code principle is simply minimizing complexity. So the more you minimize access to a particular field, the better it is. Another limitation that this keyword adds is simply the ability to clear the event. So again, if we remove it, then for example, down here, the player mana bar, this one can go into the event and set it to null. And if we test the code like this, yep, look at that issue. Basically, the mana bar completely erased the original event listener. So the player health bar, this one no longer listens to anything because this one pretty much broke the code. Again, this is something you don't want to happen with events. And again, this is something that just by adding the event keyword, the compiler will help you by enforcing some rules. And yep, like it says here, once again, same thing. By adding the event keyword, the only thing you can do outside of that main class, the only thing you can do is subscribe and unsubscribe and nothing else. So in many ways, events are indeed pretty much delegates, since they in fact actually they use delegates. Like we saw here, we are using the action delegate. But the event keyword, that one adds some really nice limitations to basically protect the code from yourself. And of course, since he used delegates, we can use anything more than just a simple action. If we want to pass in some data for the event, we can really just use a delegate with parameters. So for example, let's use an action of type int. And then over here, when we call the event, we can pass in any kind of int value. And then down here on these, in order to listen, again, the listener function needs to perfectly match that one. So if this one expects an int, then over here, we also need to put an int. And yep, like this, it will also work. And the parameter over here will be whatever you do when you call the event. Now, another thing is over here, we've been using the action delegate. You can use whatever delegate you want. You can build your own delegates, or you can use action, the built-in type. But in general, the C# standard is to use the event handler, this one right here that exists inside of system. This one has a signature where it takes in an object for the sender and an event args. So usually when invoking the event, for the object sender, you pass in this. So you can pass in a reference to whatever object was firing that event. And for the event args, if there aren't any, you can just use the constant event args.empty. So yep, just like this. But again, this is not a requirement. Like we saw, you can use pretty much any delegate you want. You can use action and everything works just fine. But generally, this is the C# standard. If you see a bunch of C# code, chances are they're going to be using the event handler. And then this one actually has a second parameter that defines what are the event args. Again, that parameter is also used with generics, so let's open up that one. And yep, it has a type of event args. So while following the standard, if you still want to pass extra data, you can. For that, usually you make some kind of class that extends event args. So here, let's make a class. And usually the standard name is to give it the same name as the event, so on player damaged. And then you simply append event args at the end. And we make this a class that extends event args. Simple like this, and then over here we add whatever parameters we want. So like for example, in this case, maybe we would have like previous health in order to know the previous health before the player was damaged. And then over here on the event handler, we use generics and we pass in our custom type just like this. And then over here, when we invoke the events, instead of event args.empty, we just construct a new object of our type and add whatever data we want. So yep, just like this. And again, on all these other ones, of course, we need to remake the function signature in order to perfectly match. And again, this is something that Visual Studio does by default, so just do plus equals, and it's automatically going to write with the perfect event signature. And over here on this one, in order to access that data, that is going to be over here on the second parameter. So we can access E, and then inside we've got the previous health, and we can do whatever we want. Also, one of the first things we saw is over here, if we do not add this null check, if we don't, then this is actually going to throw a null reference exception. So you always need to check for null. However, there's a special way to make this code a little bit more compact. So you've got the event, and again, just like this, going to fire off null if we have no listeners. So what we can do is we can use what is called a null conditional operator. I'm going to cover these in more detail in the advanced section, but basically we can just add a question mark. And basically this will mean that the code to the right side, this code will only run if the code on the left side is not equal to null. So we can do the question mark and then call invoke, which is basically going to invoke the event, and just like this. So again, the question mark basically means that it's only going to continue executing code to the right if the code on the left does not equal null. So if this one is not null, if we do have listeners to our event, then we are going to invoke the event. So instead of having a normal test for null, usually with events you have this kind of syntax. So you just do a null conditional operator and call invoke and invoke that event. Now, one of the best things about events is what I mentioned already about code decoupling. That truly is one of the magical powers of events. It's how the event publisher does not know and does not care how many listeners there are to that event. It simply fires off the event and does not care what else happens. Then all the listeners, if there are any, they will listen to that event and do whatever logic they want based on that event. This is really a crucial thing about events. Decoupling your code as much as possible is one of the best rules you can follow in order to write better clean code. And like we saw, this is especially great when games when working with the UI. Usually you want your UI to display your game logic, like for example the health of some kind of tower. You want some kind of visual for it, but you also do not want the tower itself to be dependent on some kind of visual. In theory, your game should work entirely without any UI. And by using events, this is really simple. You can just make it so, for example, over here, the tower class just fires off some kind of event, and then maybe we do and maybe we don't have some kind of external display on top that displays some data based on that event. If the UI exists, then great, but if it doesn't, then the tower works just exactly the same. So events, as you can see, are extremely useful in helping you write better, more performant, and more decoupled code. Definitely make sure you fully understand them, which if you fully understood everything in the delegates lecture, hopefully you managed to quite easily understand this lecture.